Physical Science, Module 7C, Latitude, Longitude, and Uneven Thermal Energy Distribution. We have a little bit shorter vocabulary list. This is almost the end of your vocabulary for Module 7. Be sure to record it. So latitude and longitude. Before moving to the next video, we're going to discuss a system of explaining different regions of the Earth. Geographers have divided the Earth into two groups of imaginary lines called lines of longitude and lines of latitude. Longitude are imaginary lines that run north and south across the Earth, and latitude are imaginary lines running east and west across the Earth. And here's an example of lines of latitude. Lines of latitude are labeled in angles beginning from the equator. So the equator is about halfway up here, and it's basically an imaginary line that runs between the northern and southern hemisphere. Lines of latitude are used to tell you how far north or south you are from the equator. And if you look, you'll see that you'll have the equator will be 0, and then going north you'll have 15 degrees, 30 degrees, 45 degrees. And when they actually call out latitude, they call it out as 15 degrees north. If you're going in the other direction, you'll have 15 degrees south, and so forth until you get to 90 degrees south, which is the South Pole. Lines of longitude determine your east or west position on the Earth. There's a line that we begin with, and this is called the prime meridian. It goes through Greenwich, England, and this is where it's just an imaginary line, but this is where we begin counting down our degrees of longitude. So the lines east of Greenwich are all east lines, lines west are all west lines, and they go similarly as you saw with latitude. You'll have 15 degrees west, 30 degrees west. You'll have 75 degrees east, and so forth. That brings us to learning about uneven thermal energy distribution. We talked about insolation, which is the sun's radiation reaching our planet, but it doesn't reach our planet evenly. The Earth's axial tilt causes the sunlight to shine differently on different parts of the Earth. The more directly the sun shines, the better Earth is heated. The sun's light shines most directly on the equator. That's why it's warmer there. The sun shines at an angle above and below the equator, reducing its effectiveness at heating. So the result is it's very cold on the north and south poles, because of the angle of the sun shining is what changes whether things are hotter or cooler. And because it shines directly on the equator, that's why it's very warm there. This creates a very great temperature difference between the Earth's equator and its poles. And the result of this temperature difference is what we know of as wind. When air gets hot, it expands. That expansion causes a mass of air to take up more volume. The mass of hot air is lighter than the same volume of cold air, and as a result, the hot air rises. As hot air rises, it leaves a region of low pressure. The cold air sinks, creating a buildup of air, and creates a high pressure region. When air builds up at one location and leaves a deficit in another, it tends to move from the buildup to the deficit, trying to even the amount of air everywhere. So when the air moves, we call it wind. So air is constantly trying to create this balance of high and low pressure, and that's what creates wind. Consequently, temperature differences result in wind. Warm air rises at the equator. That creates a low. Cold air sinks at the poles. That creates a high. At the Earth's surface, wind blows from the poles to the equator. In the upper atmosphere, winds blow from the equator to the poles. So not only do you have these heat differences and pressure differences causing this wind, but they actually blow from different directions, closer to the Earth and farther from the Earth. There are several factors that complicate how thermal energy is distributed. Changing air temperature, cold air moving from the poles to the equator encounters warmer air. The warm air rises, causes a high at the upper altitudes. The high air moves the air back towards the pole, and this consequently causes a loop of winds traveling continuously from the poles to the equator and back again. And at the equator, the opposite takes effect. So, taking a look at global wind patterns, loops of wind are created by this constant rising and warming and then cooling and lowering, and it creates these loops. It also creates these loops to change direction, and obviously they're not neat like this. They interact with each other also. A loop of wind caused by warm air at the equator rising and traveling north. As the air cools, it sinks and changes direction. So this is what happens. It starts here, goes north, it gets cooler, and it comes back. Now, while the air is moving, the Earth is also spinning, and this distorts the wind directions. This happens because each latitude north and south of the equator rotates at a different speed. And that's very detailed, but if you can imagine traveling across the equator, that is the widest part of the Earth. And so it will take you longer to travel across the equator. But if you're up near a pole, or down near a pole, I should say, you'll have a shorter distance to travel. So the rotation will be different depending on where you are at the Earth, and with a different rotation, it'll have a different speed. When an object travels above the Earth, its path will bend depending on where it originated and where it is going. This is called the Coriolis effect. And the Coriolis effect is the way in which the rotation of the Earth bends the path of winds, sea currents, and objects that fly through different latitudes. So you can see that in this picture they have these rockets, and if you shoot off a rocket, it just doesn't go straight in its orbit. It actually begins to bend because the Earth is rotating. So this creates an actual more realistic pattern here on this drawing of wind currents. And just it gives you an idea, because of all of these factors that we've talked about, you can see that there are bands of winds. Some are going from west to east, some are going from east to west, and they actually call these the westerlies. The ones that go from east to west are the trade winds. And then at the extreme poles of the Earth, you have what they call the polar easterlies. Another thing that creates this uneven energy distribution is the fact that all of these things contribute to what we call sea breezes and land breezes. Because land heats up faster than water during the day, the land's warmer than the water. This temperature difference causes a surface breeze that blows from the water to the land. And then because land cools faster than water during the night, the land is cooler than the water. This temperature difference causes a breeze opposite the one that happens during the day. This is a lot of information. If you need any assistance, please be sure to contact me, and we'll have time to discuss it in class.